Hello everyone. Now let's start solving the question. The question number 1. It is saying that the radial distribution function does not depends upon. Radial distribution function, we know that it is equals to, that is 4 pi square, pi r square and capital R NL r whole square. So the first statement is the distance from the nucleus. Yes, this is depends upon the distance of the nucleus. The principal quantum number, yes, it is depending upon the principal quantum number. Azimuthal quantum number, it is also depend upon the azimuthal quantum number, but it does not depends upon the orientation of the orbital, and orientation of the orbital is shown by ml, that is shown by ml. So the correct answer will be D. Coming to the next question, which one of the following statement regarding the wave function is not correct? So the first statement is that wave functions are three-dimensional and contain three quantum number n, l and m. So that is true. Actually, to describe a wave function, we need the principal quantum number, that is n, azimuthal quantum number, that is l, and the magnetic quantum number m. And the second statement, the wave function represents the total movement of the particle over a period. So I think this statement is incorrect, because a wave function does not describe the movement or trajectory of a particle in a classical sense like a path. Suppose this is a wave function, it does not tells about the movement or trajectory like classical, not like that. So this is not an appropriate statement. And probability density is interpreted as a square of the wave function, that is also true. So the probability density, that is psi square, this is the probability density, and wave function should be differentiable. We can differentiate the wave function with respect to any variable. So the not correct statement will be B. And coming to the third question, in which the following statement regarding the electron configuration of the atom is or are correct? So first of all, the principal quantum number, one suggests the case cell, example helium. So in this problem, the helium electronic configuration is 1s2. So electron is staying in the 1 and the n value is 1. So that is a true statement, and 1 represents the K cell. And coming to the neon, this is 1s2, 2s2, 2p6. So n is 2, so this is L. Okay, but here this is M, so this is not a right statement. Coming to the third statement, the principal quantum number is 2 for L cell of fluorine. If we consider the fluorine is 1s2, 2s2, 2p5. Then n is 2, that is true, and it represents the L cell, so that is also true. Principal quantum number 3 K cell, 3 does not represent K, so this is not. So 1 and 3 is the correct statement. Coming to the question number 4, which one of the following represent the correct order of boiling point among lithium, beryllium, boron and zinc? So basically here we have to predict the boiling point order. So if we compare the position in the periodic table, so lithium and that's beryllium and boron, and another component is zinc. This is one period, this is second period and third period. This is sodium, lithium, sodium, magnesium, etc. Then fourth period, potassium, calcium. Then here the transition metal series, and here we will get the zinc. Okay, so the comparable things are this and this. In general, the boiling point BP, that is directly proportional to the intermolecular forces. In the molecule. So actually let's consider that if there is a lithium atom and another lithium atom, the interaction between two atoms, that is the intermolecular forces, that will determine their boiling point. So in this case the boron has the highest boiling point, as we know that we have many compound of B2A6, they can form the giant structure, they can form giant network of compound. Due to that, we can say the boron containing compound has the highest boiling point. So both these options are eliminated. Now between the beryllium and lithium, the beryllium has the more boiling point than lithium. Why? Let's erase it. Beryllium, this is lithium, the electronic configuration is 1s2 2s1 and it has 2s2. So as it has more s electron, so more proton, nucleus, so Z effective I. So that's why the beryllium has more boiling point than lithium. And the third case, zinc has the least boiling point. Let's describe this. Actually in the zinc, for zinc it is a transition metal and the electronic configuration is 3d10 and 4s2, and as all cell filled, so it will form weak metallic bonding. So the correct option will be this, D. Now coming to the next question, that is question number 5, the correct group period and block for the given element. So to solve this kind of, this is the atomic number of the element, we have to find its group and period. So actually to solve this kind of question, we have to subtract its atomic number from the noble gas configuration. So from starting from period 1, let's see the noble gas electronic configuration, the atomic number. Total 7 period. First of all the helium, then neon, atomic number 10, argon, this is 18, krypton 36, xenon 54, then 86, 118. So the easy technique is that first of all the difference is 8, then 8, then difference is 18, difference is 18, and then 32, 32. So if we subtract from 180 the 108, we will get minus 108, we will get 10, and this 10 number we have to subtract from the 18 group. Okay, so 18, suppose this will equals to, suppose this value is 2, so you have to subtract 18 minus 2, this belongs to the 16 group. Okay, like this. So the group number will be 18 minus 10, that is 8. So in the modern periodic table 1 2 3 4 5 6 7 8 9 like this order. So from 1 to this is S block. After that this is the D block started, and 118 means this is the 7th period element. So this is 7 period, 7 period, 7 period. So 3 options. Now we finally get this is the 8 group, and this is the right answer. Coming back to the next question, the question number 6. Consider the following statement regarding the modern periodic table. Element in group 16 also known as a chalcogen. That is true. This is statement based question actually, so this is correct. And element in group 3 to 12 are known as a p block. Not, because 3 to the p block element is 13 to 18. The A block elements are also known as an inner transition element. That is also a true statement, because it will occupy the n-2 F cell. So that's why this is called the inner transition element. And element group 13 and 18 are known as a transition element. Not true. This is the 3 to 12. Okay, group that is known as a transition element. That is not true also. And element in the group 2 are also alkaline orbital. Yes, this is belongs to the S block, alkali metal, if the group number is 1. So correct option is 135. Option number C is correct. Okay, coming to the next question number 7. Which one of the following statement regarding the general properties of the S, P and D and A block element is not correct? So first statement is that the compound of S and P block element are mostly white in color. So basically most S or P block, they are basically colorless or white in color, because they don't have the d orbital, where the d kind of transition, this is absent in them. So this is also true. This is true. All the S block elements are metal. That is also true, because first group, the alkali metal and the alkaline metal, they are the metals generally. And the third, most stable oxygen state for all the lanthanide is +3. That is also true, because Ln3+ is the stable one. They generally exist in the +3 state. Coming to the D, the complexing ability of the lanthanide is more in comparison to the D block. That is not a true statement. So the correct statement is D. This is not true, because we know there is a several complex of the D block element, but for A block the complexing ability is low. Why? Because the transition metal have small radius, the ionic radius is low, so the complexing tendency is high. On the other hand, the A block element, the radius also high and ability also low, and the F orbital, this is very inside, buried inside. After a D there is a S orbital, there is a P orbital, so it is buried inside. So that's why it is hard for A block element to form various compound. So correct option is D. Now coming to the question number 8, the ionic radii question. Which one of the following order of the ionic radii are correct? We know that the radii is directly proportional to the negative charge and inversely proportional to the positive charge. So if we see the first, here the anion forming the electronegative atom forming the anion, and here the electropositive atom forming the anion. When the electropositive element are forming an anion, it has high radius. In the first option, of course, the tellurium 2 minus is the highest ray than the selenium 2 minus. So the first option is correct. And if we consider this is 4 plus 3 plus, the ionic radius is decreasing, but here increasing. That is not a correct one. And the ionic radius O2 is the highest, so that is not also true. So option number 1, only one will be correct here. Actually same group. So down the group, we know that the size will increases. If it is forming the anion, its size O2 minus 2 minus 2 minus 2 minus, its size also increasing. So that's why this will follow this order. Coming to the question number 9, this is all about the effective nuclear charge. By using the Slater rule, which one of the following is the correct value of the effective nuclear charge Z effective for the 3D electron of the chromium? So first of all, let's write the chromium electronic configuration. This is Z is 24, 1s2, this is 8, otherwise we can write that 1s2 2p6 3 6, then 3d5 4s1. This is general electronic configuration of chromium, and here we are talking about this electron. First of all, the Z effective is equals to Z minus the shielding constant. The shielding constant is equals to the other d electron available, the contribution of other d electron other than 1 electron. So this will be 4, as there is a 5 electron, so that's why except 1 electron, other will be responsible, other 4 electron will be responsible for the effective nuclear charge, 0.35 each, so that value will be 1.40. okay, and wait a minute, and plus other than this, the other will be 6 8 8 16 17 18, so 18 into 1 each, so final value will be, this is 19.40. now Z effective will be, this is 24, this is about 4.60. so correct answer is C. Which one of the following represent the correct order of the solubility: lithium carbonate, sodium, potassium, rubidium, cesium? So this is the alkali metal carbonate. We know that same group, lithium, cesium. This is the order. So basically for the alkali metal carbonate, alkali metal carbonate, what happens that the lattice energy U is decreases rapidly than the hydration energy. This is that is decreasing more rapidly than hydration energy. So what happens here, that lithium CO3, Li2CO3, it has the highest lattice energy. The lattice energy will be highest due to the small size. This is the small radius, small size, so lattice energy is, we know that is inversely proportional to the radius, so that's why it has the highest lattice energy, and this is least soluble. down the group, as the size is increasing, the lattice energy will be decreasing. Okay, so that's why the solubility is increasing. So the final order will be the cesium carbonate has the highest, then rubidium, then potassium, then sodium. This is the correct option, the option number B. Coming to the question number 11, which one of the following is expected to possess the highest electronegativity? So all the elements belong to the same group. This is same group, that is 13. Okay, here the electronegativity is not simple, as it shows the anomalous behavior. Why? The electronegativity of this element are not vary linearly, but is differently. So we know that down the group the electronegativity also decreases, but it is not true for this 13 group element. So if we compare that aluminium, gallium, indium, thallium, it is so that the tellurium has the highest electronegativity, then gallium, then indium, then aluminium. So this is actually you have to memorize, otherwise you can't able to do this question. So the correct answer will be D. The 12 number question is in the catenation. Consider the following statement regarding the catenation tendency of nitrogen. Nitrogen has the weaker catenation tendency than carbon due to the repulsion between the non-bonding lone pairs, and that is a correct statement. We know that this is nitrogen, this is hydrogen, this lone pair and this lone pair will repel each other, but in case of CH3 and CH3 no lone pair is present, so that's why this is a stable compound. Single bond energy of the CH3 is much higher than the, that is also true, it has more high bond energy than the nitrogen due to the lone pair repulsion. 3 or more nitrogen atom can be joined through the multiple bond. We know that N2 exists by 3 more multiple bond, so that is also true. So 1, 2, 3 are correct. The question number 13, which one of the following expected to exist in the gaseous state? So this is actually database question. So correct option will be this, tungsten hexafluoride, and another characteristics is that this is heaviest known gas at okay, if we and this is exist in the liquid state, while this in the solid, and this exists in the solid state. So correct option is option number A. Coming to the question number 14, which one of the following metal ion is diamagnetic in nature? Titanium 3+, this is the D1 system. Vanadium 3+, this is D2 system. Copper plus, this is D10 system. D7 system. So this is the diamagnetic one. Which one of the following is the most unstable in nature? So TF5, this is all exist, this is stable. We know about the SbCl5, this acts as a Lewis acid. Bismuth F5 also exists, but the correct answer will be B, arsenic pentachloride. So this is very unstable. It decomposes to give the arsenic trichloride plus chlorine gas. For arsenic, Cl5 plus 5 oxygen state is unstable. Why? Due to inert pair effect. Due to inert pair effect, this is unstable. So that's why this is broken to the Cl3. This is 3 plus state and it is a stable oxygen state. And that's why the option number B. Now coming to the question number 16, the hydrolysis of the silicon tetrachloride proceed through. So in the silicon tetrachloride, the reaction is proceed through basically SN2 path. SN2 path. Actually silicon has d orbital, chlorine, so it can accommodate the water. Okay, after that is both will leave, it will generate the SiOH Cl3 plus HCl. So this is possible due to the presence of d orbital. Presence of d orbital. This is not a SN1, SN2 kind of mechanism, because this water molecule is attacking this, and after that the chlorine will release. Proton transfer, not a proton transfer, not a reductive elimination kind of mechanism. So option will be SN2. Which one of the following combination of the products which are formed during the reaction of diborane with the oxygen and water? So this is a simple reaction. When B2H6 or diborane reacted with the oxygen, this will generate the B2O3 plus H2O. If we balance this, this is 3. On the reaction with the water, OH whole 3 plus H2. If we balance this, boron 2 boron, then 6 oxygen, 6, and this is 6. So you'll get the B2O3 and BOH. This is the correct option. Now in the next question, question number 18, the radius of Na plus is that 0.95 and that for the chlorine 1.81. In which one of the following sites of the Na plus will prefer the occupy? So first of all we have to see the radius ratio rule. R plus by R minus 0.95. Sorry, this is 1.81 and the value will be about 0.525. So 0.4142, 0.732. This is belongs to the octahedral. Okay, so correct option will be octahedral. And so I will prefer to occupy the crystal lattice and chlorine of chlorine minus ion. Octahedral and coordination number will be 6. 19. Consider the following information available the ionic binary compound. Middle and constant, that is represented interionic distance, charge of the ion Z plus Z minus, ionic radii of the. Which one of the formulas given is required for estimating the Bornland equation? The Bornland equation is given as that lattice energy is equals to minus Avogadro number into Mendelian constant into charge of cation, charge of anion into the electronic charge divided by R square. 1 n is a constant. So estimate the lattice energy. First of all, Mendelian constant yes, interionic distance yes, charge of the cation and anion yes, and ionic radii of the, not the ionic radii of this, but the interatomic distance. So 1, 2, 3 are the correct answer. Coming to the question number 20, which one of the following statement regarding the polarizability is or are correct? The small and highly charged cations have the high polarizing power. So polarizability is directly proportional to the cationic charge, and higher the cationic charge, more will be the polarizable. Directly anionic, this is positive charge actually, and this is negative charge. So if the cation is charge by radius, actually directly proportional to the charge divided by radius. So small highly charged cations have high polarizing power, that is true. Large highly charged anion are easily polarized, that is also true. Cations do not have noble gas electronic configurations, are easily polarized, that is true. If we consider that cation, suppose magnesium plus, this is about the 3s1, okay. This cation does not have the stable electronic configuration, so cation, they are easy to polarize. Then the sodium plus, okay. So the option 3 also correct, so correct answer will be 1, 2, 3. So by that we are able to complete the 20 questions of GSI prelims 2026.